Hi everyone, thank you for watching Laugayata. You can post your chemistry related questions in the comment section and I'll make a video solution for that. In this video, we'll see how can we predict the direction of the reaction depending upon the values of K and Q. So what is K? K is the equilibrium constant and Q is the reaction quotient. So basically we need to understand what is the difference between the K and Q. So let's see a very common example which is used to understand the chemical equilibrium. So the reaction is A plus B gives C plus D. Now according to law of chemical equilibrium, if we want to write the equation for the equilibrium constant, it can be written as K is equal to Cc multiplied by d raised to the power d upon a raised to the power a multiplied by b raised to the power b. Okay, now this is the equilibrium constant. So it means that it is the value when the reaction is at equilibrium. But if we want to predict the ratios of concentrations of products upon reactants at any other instant, at any other stage, then it is called as reaction quotient. So the equation is exactly the same as the equilibrium constant. So it is C raised to the power C upon multiplied by D raised to the power D upon A raised to the power A multiplied by B raised to the power B. The only difference between the two is this is for the reaction already at equilibrium and this is at any stage. Okay, now you need to understand one thing, that Q always tends to become equal to K. So if Q is greater than K, then it will try to decrease itself so that it becomes equal to K. And if Q is smaller than K, then Q tends to increase so that it becomes equal to K. Now let's see how does it do that. Now first let's see when Q is greater than K. Now let's consider the same reaction, which is A plus B is in equilibrium with C plus D. And the equation for the reaction quotient is Q is equal to C raised to the power C D raised to the power D upon A raised to the power A and B raised to the power B. Now I already told you that if Q is greater than K, then it tries to decrease itself so that it becomes Q equal to K. Right? Now let's see here. We are saying that Q is greater than K. So it means that the products are greater and the reactants are less. So more of C and D are present and less of A and B are present in the reaction at this instant. Okay. Now if Q wants to decrease itself, so it means that it has to decrease the numerator and increase the denominator. So how it can do that? It will try to move in the reverse direction such that C and D will be consumed and more of A and B will be formed. So it means that if Q is greater than K, then the reaction will move in the reverse direction such that the value of Q will decrease and it wants to become equal to K. Okay, now let's see the second case. Now second case, I already told you if Q is smaller than K, I am writing the same equation, which is A plus B is in equilibrium with C plus D and the value of Q is C raised to the power C D raised to the power D upon A raised to the power A and B raised to the power B. Now again here you can see that the Q is lower. So it means that this value is low. If this value is low, it means that the numerator is low and the denominator is high. So this shows that the concentrations of C and D is low and the concentrations of A and B are high. So it wants to increase itself. Q wants to increase itself such that it becomes equal to K. How will it do that? It will try to increase the concentrations of C and D. So the concentrations of C and D will try to increase and A and B will try to fall down. So how will it do that? The reaction will move in the forward direction such that the concentrations of C and D will increase and the concentrations of A and B will decrease. So it means that if Q is smaller than K, then the reaction will try to move in the forward direction such that the value of Q will increase and it will try to become equal to K. And the third case is when Q is equal to K. So if Q is already equal to K, then it means that the reaction is already at equilibrium. So this was all about how to predict the direction of the reaction depending upon the values of Q and K. Please like and subscribe to the channel Log Iota and press the bell icon